Cool. Hi, everyone. I'd like to thank everyone who's joining us today. So welcome to our CNCJ July meetup event. My name is Harry Lee. I'm the organizer of CNCJ. Today we have Lepolesa joining us, who will be sharing with us on how to transform into a zero-bug developer on Kubernetes. So just a few housekeeping items before we get started. This session is scheduled for an hour. However, we will leave the Zoom meeting open if people would like to continue their discussion after the presentation. So we've given this session a technicality rating of 2 out of 4. So there may be some Kubernetes terminology and geared towards an audience that has some Kubernetes experience. Questions are always welcome, but please keep them on topic. So as not to disrupt the session, Lepolesa will answer your questions at the end during the Q&A session. So we want to make this session as interactive as possible. So you will get a chance to speak if you choose to. You can also just put your questions in the chat panel. Cool. So this session is being recorded and moderated. So please be respectful towards the speaker and your fellow participants. You will be kicked out if you do not abide to our code of conduct. And this session will be available on YouTube under the official CNCF community YouTube channel over the next 2 days. So with that, I'll hand it over to Lepolesa to kick off today's session. Okay, Lepolesa, the floor is yours.
Okay, thank you, Harry. So hi, everybody. So today I just want to look into how we can sort of transform our developers into zero bug. Yeah, we know that we can't really get to zero bug, but how can we sort of minimize it by using the tool called DevSpace, developing inside. So kind of developing in Kubernetes. Yeah, so yeah, I'm just gonna check. Looks like, all right. So, developing in Kubernetes is quite a tedious process. So it has it involves a couple of, I think my slides don't move that well. Okay, I'm just gonna check here. Sorry. Okay, cool. So it involves a couple of commands. So we know that you have a couple of tasks that you need to run. So basically to be able to develop, you need to sort of first build your image, and then after building your image, you sort of have to push it to the ECR repo or to the repository or the registry. And then after that, you sort of need to run some commands to get it across to Kubernetes. And then if you are developing, and then you need to do this a couple of steps. So these steps become repetitive. So you sort of do them over and over. And then so for our new joiners, we sometimes kind of rely on the runbooks to sort of define the process, the commands and the tasks that are involved. But as we all know that a lot of times those runbooks are outdated. So yeah, it's not a lot of times you go to a README inside of a repository, and then you find out, okay, the README is outdated. So somebody says, okay, we stopped updating that a long time ago. So this is so what we get. So and then so if we look at our configuration, sometimes they're not very local to our code base. So when things are not local to our code base, we don't care about them that much. We feel like it's somebody else's responsibility. So you find that we have things like the Helm charts and stuff that are defined somewhere else, and then we just concerned about just packaging our code and then pushing it, and then a lot of times we sort of start relying on our CI/CD pipelines to sort of deploy our to our development environment, and then that's when we can start testing. So basically, this is what our development, our CI/CD pipelines look like. So this is before we actually get our code or our feature across to our development environment. As you can see, that we have like the build pipeline, and then we have the release pipeline. So if we look at and then we have the code review. So if we look at the time that we take before we can actually get to our development environment, it takes quite some time, depending on how quick the code reviews and then how quick our pipelines will get our feature across. So in the past, in the past, we have seen us kind of moving a lot of stuff to our development, our developer domain. So our developer domain on the green line, on the left side of the green line is sort of our safe space. So where a developer is comfortable, so feels kind of free to break and change anything. So in the past, so not in the past per se, but we have always had the building and the unit test. So if you look at from our pipelines, we have the build and then the unit test. So they have always been closer to the developer. So then I think later on we moved. Then we had Docker, our Docker file, which is our packaging, so which defines where our system is going to run. So it's actually closer to us as developers as well. We can do things there. And then we have seen static analysis as well. We have seen static analysis moving closer to the developer as well. I remember in the past, you would actually write your code and then push it to the pipelines, and then it would come back and tell you have like so many null violations of null pointer. It was not handled, and then you have already written like 100 lines of code, and then that time it will just report to you after you have actually written this. So then we have seen the rise of linting. So nowadays there's a lot of linting, so it's incorporated in the IDE. So as soon as you're writing the code, you're getting the feedback. So the feedback is much faster. So the question is, why can't we do the same with our environment as well? Why can't we go on and then get our environment kind of closer to the developer as well? So why do we really need to sometimes get our environment closer to the environment, to the developer? So there are a couple of things. So we have realized that Kubernetes is kind of just not about scaling our workloads anymore. So it has turned into some traffic management. So that's how we manage how things talk to each other, and then some access control. We manage our configurations there. So you find which is what I've seen a lot, that you find that certain configurations are missing, or we have tested the configuration in our local environment, and then that configuration now, when we start pushing to our pipelines, that configuration was not accounted for. So now something is breaking, so we end up trying to debug it. So we involve someone who didn't even know about it to try to debug the issue, and then they don't even know that there's a missing configuration. So there are privileges as well, or sometimes as a developer, you sort of want to do something on the host itself. But then there's just privileges that will be preventing you from doing that on the Kubernetes environment itself. There are other services that other applications that we build that rely on Kubernetes native services, such as service discovery. So I've seen a lot of that in it's called Cloud Kubernetes, Spring Cloud Kubernetes. It has its own, it's using service discovery. So sometimes you need to make use of that. So you want to test your applications against that on the actual environment. And then external services. So some external services are kind of have limitations. So what I've seen in the past is would have an external service, and then that external service would need us to whitelist certain IPs. So those certain IPs, you find that they are for our environment, like our dev environment, our staging environment. So now if you want to test against such services, it becomes a lot harder, because now you can't just do it from your PC. You'll need to actually do it from the environment itself. So there are other cloud services as well that when you configure them, they sort of have callbacks. And then the way you configure your callbacks is to sort of call back to your environment. So you have your development environment. So your development, the service that is working with the development environment will actually do the callbacks to the dev development environment. So yeah, so then the big one is sometimes we have resource constraints on our local machines. So I mean, in the past we used to just spin up. So we would have our application and then its dependencies, and then would use tools like Docker Compose, and then would test our application again together with the dependencies, and then we'll build some sort of confidence that our application is going to work in the way we think it is going to work. So like if we look way back when we had monolithic systems, things were much easier because we could just test just that one giant application. And then there was a variant as well that came in, and then we could build our own test environment on our local machines. But now we know that dependencies might not just be 2 or 3 services; it might be a couple of services. So we might have resource constraints for that. So we might not be able to run it on our machines. So it would be better if we just run it on our development machines. Yeah. So yeah, what is so DevSpace will sort of help us with this. So I just want to talk about what it is. So yeah, according to documentation, it's sort of a client-only open source development tool for Kubernetes. So it helps developers build applications faster. So so it helps you can build test and debug applications inside of Kubernetes. So it gives you sort of things like hot reload type of things, the things that we normally accustomed to as developers. So it gives you that feel like you sort of doing things on your machine like you normally develop on your local machine. So it codifies our workflow. So the how we build images and then how we deploy. So these are sort of codified, and then this become part of our source code, so we can share this. So it's like when you have scripts that say how we, or the run books that say how we do things. So this sort of codifies them, but then it sort of makes them much easier because you now don't have too many commands that you need to run. It's more like when you have scripts that you create for your team to actually run stuff. Yeah. So yeah, so those repetitive tasks that we've seen when you have to kind of do things a couple of times to get your work going. So it sort of automate those repetitive tasks, and then so even the infrastructure definitions, I see them moving closer to the code base. So I have I believe that when your infrastructure definitions is closer to your code base, as a developer, you start caring about it. Unlike when it's really in someone else's code base, it feels like it doesn't belong to you, and then you don't sort of want to fiddle with it a lot because you might mess up some stuff. And yeah, so yeah, so this under CNCF, that's a big landscape under CNCF. So it's under the application definition and image. Yeah. So yeah, so that I went through that very quickly. Yeah. So now for our demo, just gonna be interactive. I just wanna show you how it sort of works. So yeah, just close this. Okay, good. Okay, so I have. Can you see my? It looks stuck on my side, so I don't know how it looks from your side.
Yeah, so we can see your, I think Visual Studio code.
It doesn't look very dark. Okay, so to get going, so with this DevSpace, so you can install it using npm. So that's what I used to install. So you can just use that command npm install -g, and then because I've already installed it, I'm just gonna do that. So, and then in your code, or in your code base, in the root directory, you can sort of initialize it with this command, and then it will sort of create DevSpace.yaml in your root directory. So I already have that. So I already have many of them. So yeah, this one to create a file like this one, and then you can tell it the context. So you can switch the context, like we normally switch the context when we use kubectl. So you can use DevSpace, use context, and then you can sort of tell it what namespace you actually want to use. So I've already configured most of that. So yeah. So now I'll just want to go through the structure of the DevSpace YAML. So the DevSpace YAML has a couple of things. So it has the image section, deployment section, profiles, hooks, variables, and then it also has dependencies. So I can just show you dependencies now. So it also has dependencies on the way it is. So it has this section, dependencies. So I'll show you that how those work. So yeah. So let's first look at the image. So in the image is sort of how you define your images. So you can sort of define images, and then so you normally what you have is your Docker image, which is production ready. So you have your Docker file that you have that is to production ready. So now when you develop in Kubernetes, you may want to not necessarily change your Docker file, but what you want is to sort of add certain things that will help you with your development. So what you normally do with that is DevSpace gives you an ability to sort of append to Docker file whatever you want to append, and then it gives you so you can sort of override things like entry points, and then you can override the CMD as well. Yeah, so you can do a lot of stuff. So, and then you can inject the restart helper. So you'll see what the restart helper actually do. So on this build section as well, so you can build using any tool. So I'm just using Docker. So you can use I think you can use Kaneko, and there's another one, build tool, I think, build kit. Yeah, you can use that, or you can write the commands as well to do that. Yeah. So, and then you can build many images. You can have them in parallel as well. So on the deployment section, so this is how you deploy to your environment. So what I have here, so I've created a simple manifest here. So I'm going to use kubectl to do this. So I've created a simple manifest with a deployment as a service. Yeah, so that's about it. So in the deployment here, you can also have a couple of things like you can use Helm, you can use customize, and then there is another one that DevSpace comes with, which is called component chat. So you can sort of just pass in the values, and and then sort of create some so like using chart values, and then create sort of a Helm chart from that. Yeah. So development section, here's where things get interesting. So this development section is it's actually where you actually tell it what to do, or you tell your environment what to do. So like here I have pods. So in the pods I want to port forward this certain pods, so that I get them as local hosts. So I'll get this as local host. And then if I want to open, I can use that to sort of open the URL. You'll see how this works later on. If you sort of want to do auto reload, so how auto reload works is whenever you change something, it sort of reloads your workflow. So you can sort of tell it you want to reload your workflow when you are doing when you have made a change to your image, or do you want to do it when you have made a change to your the deployment, or do you want it to change when you have actually made that to your path? And then there is sync, which this one is quite interesting. So the syncing, how it works is it syncs your file that are local to your Kubernetes. And then if you have the sync, and then you have this on restart container, so it will use from the image here, it works together with this inject restart helper. So it will not kill your pod. It doesn't kill your pod. What it does is it just syncs your work every time let's say you're working on a project, you're typing stuff, and then you're saving them, and then so that normally how the auto hot reload works is you'll be typing your things, and then it keeps on updating the code to the latest. So your server always has the latest. So it works in a similar way. So you can for things that already have the auto the hot reload, you don't need to sort of have the restart container. So for things that do not have, so you can have this, and then it'll act as if it has a hot reload. Yeah. So yeah, so there's a couple of things in there. So like the replace pod. So replace pod, you can sort of replace inside your pod. You can replace the manifest. You can change the manifest of the pod. Like here, I wanted to change one thing. I wanted to change the container spec to add this image policy, and then to be always. Yeah, but this was sort of taking time because it was taking time to kill my pod. So yeah, I'll show you that later. Okay, let me just close this section. So on this section, we have profiles. So you can define your profiles. So I have a couple of profiles. I have 3. Okay. So in your profile, so you can sort of do interesting stuff as well in the profile. Yeah, so for my profiles here, so I will still want to use the image build, but then I want to patch it. So what I'm doing is I'm patching this section here. So when I'm patching that section, I'm saying, okay, from that section, I wanted to remove what I've appended. So you can just go in and remove what I've appended, and then it can remove the what I have injected as well. So I can also tell it to remove the entry point. So it will remove all those, so that when it builds my Docker file as it is. So without stuff that I wanted to modify in there. And then I have this debug one. So in the debug one, what I'm doing is I'm just replacing the entry point. So from the entry point, I want to replace it with, I want to sort of add the remote debug address. So I'm in that, I just want to start my application in debug mode. Yeah, so I'll show you that later. And then I want to do the append. So I want to add to the instructions, I want to expose the port. So it will add this to the image, and then it will expose that port. Yeah. So the interactive one, what I'm doing is I'm just replacing the entry point, and I'm just making it sleep so that it doesn't die, so that my port doesn't die. It takes forever. It's not die. Yeah, so that I can sort of run the commands inside of that container without it dying. Yeah. So yeah, that's about it from the profiles. And then we have next we have the hooks. So the hooks is it's like what you want to run before or after certain sections happen, like after deployment. Maybe you want to do something or after the image build or before the image is building, you want to do certain things. So for me, what I did here, just for this, it's not really a clean way, but I have this command here that will actually check if I have my jar that exists, and then if it doesn't, it will build it, and then after that it will build the image because my image actually needs that jar. And then so you can also run commands inside the container. So when the pod starts, you can sort of run your commands inside the container. So then there is commands. So you can so some commands are just long. So you can sort of simplify them by creating your own commands. So if you have something that is super long, you just go on and then create those commands, and then it sort of makes it easier for developers to go in and then run a simple command to do certain things, rather than trying to change those commands themselves. Yeah. And then we have variables. So the variables here, you can sort of ask them to put in the variable, or you can sort of so there are various ways you can get in the variables there. And then it has a variable file as well that you can configure the .imp. Yeah, so yeah, that's about it from there. So I don't know if I should talk about the dependency as well. Okay, let me just go to the dependency. So on the dependency side, so so when you have when you have the application, so like in Docker Compose, what we did is we had our application, and then we would run it together with its dependencies. So DevSpace has this similar concept, so where you can just pull the dependencies as well, and then run them together with your application. So what happens is it's able to pull the dependencies either from remote, like from Git. You can use Git to pull your dependencies, or you can just use the path like I did here. So it's just pointing to direction here. So this will be pointing to that. So but those dependencies should also have the DevSpace file as well, so that because it's going to try to run that workflow when you pull the dependency. Yeah, cool. All right. So now, okay, let's see how this works in action. Hopefully, so I have a Kubernetes cluster that is running and DigitalOcean, so it's in London. So I wonder if it will do what I want to do. So this is my Kubernetes cluster. So it's very small. I didn't make it very big, so hopefully it will do stuff. Yeah. So cool. So now I'm just gonna run. Okay, DevSpace. So I've already pushed the images. So hopefully things will not take long. So when I run DevSpace dev, So these are the variables that I've set, where I've said, okay, it must ask me. So I'll just go back to the code and then show which section that is. So this is the variable section. So that is the question. So I'll just click on that. So once I do this, it creates a dot DevSpace. So it acts as a cache. So it sort of caches everything. So that I don't have to keep on going back and then make this creating the same variable. So it will be saved in the cache. So I hope this goes fast. So now it went to the image section. So it builds my image, and then after that, it pushes it to my Docker Hub. So there are various ways you can go about the image. You can decide, okay, I don't want to put the image. What I want to do is I want to pass my image or just have this image that I'm saying, okay, this is image that I use to test things, and then you can just pass it in, and then it will still work. Yeah, so after that, it will go and then deploy everything into Kubernetes. Yeah, and then it will sync the files. Now it's syncing the files into that. So yeah, the thing is, I couldn't get the target to only write one file, so I tried to fiddle with it a bit, but yeah, it's not really fancy, but it's doing the job. So now, so after this, it will sort of run the entire application. Then I'll interact with after it's finished. All right. Okay. Sure. All right. Okay. Now, so I chose Java because I thought, okay, Java is a stubborn programming language, so just choose something stubborn. Yeah. So now if I go, so I call my local host. So I've already just the DevSpace has already done this port forwarding for me. I don't need to do it again. So if I do that, it's done. So I'll get the response. So now what I want to do is I want to go back to my IDE, and then I want to change something. So I'm just gonna go and then change the configuration. So I'll change the configuration. I'll try to uncomment that and then save it, come to my terminal, and then do okay, I just need this command. Okay, just copy it from somewhere. No, somewhere. Okay, my command. So I'll just copy that one. I just want to skip the whole testing. Okay. So now if I run that, so let's show you. So now it's done. So now DevSpace will actually try to, it just syncs the files, and then it will restart my container. So just a restart takes a couple of few ones, because I didn't, I realized when you save, when you just press save on Java, I think the Spring Boot plugin, it writes the class files and the test class files, and then DevSpace thinks that you have changed something. So yeah, so after this, so we'll see if it's running now. Yeah, so now you see it has taken the changes. So I didn't have to stop my pod from running. I didn't have to rebuild the image. It's just I'm just developing, changing things, and then things are just happening directly inside my my container. So the container keeps on restarting, and so it gives me that local host experience. Yeah, and yeah, imagine when you have to debug and then you can just do this and then change a couple of things. Yeah, so that was the section for, yeah, about how we can sort of leverage the just developing inside the container without really restarting or running too many commands. As you have seen, I just ran just a single command for this, and then everything actually works. And then I can just change my code anyhow I want to, and then it will still be running. I don't have to change anything. Yeah. So the developer will just run this once, and then they will develop, and then they will change their code and anyhow, and then save it, and then build it, and then it will build their, it will deploy their stuff inside the container without really killing the pod and then restarting it. So this makes things much way faster. So I'm just gonna show you the command section, how we can use the command section, which is this one. So in my command section, I'm running so DevSpace dev, the same command that I ran, but now I'm picking the profile that I want to use. So my profile is the debug profile. So what it does is just replace the entry point, and then it appends, it exposes that, and then it appends this entry point. It adds remote debugging. So I'm just going to run that. Hopefully it works. I don't have to purge. Okay. Maybe let me just purge. I'm just going to purge. I'm just going to run DevSpace purge. So I just do it from my clean stuff. Okay. So I realized that with DigitalOcean, it takes a couple of seconds before it terminates. So things take a longer time in terminating state. So I'm just going to try to remove it myself. Okay, hope this will not be a situation with our developers. Yeah, so there we go. So now what I'm going to run is I'm going to run the debug. So just gonna run DevSpace run and debug. Hopefully it will work. Okay. So what it will do is it will go and then execute the workflow the same way we did, but just skipped the other part where it's pushing. So the skip in my command is skipping that because I already pushed that image. So, so it's just my fault. I could have written it in a way that it shouldn't even try to build, but because when I do a syncing, I'm doing a two-way syncing. So in the two-way syncing in my container, I change my jar file. I change it to from the stock manager snapshot. I'm changing it to app. So that file gets synced from to my computer as well. It's a bi-directional syncing. Yeah. So when I try to rebuild it, it looks at that and then it thinks, okay, that is no longer there. So it needs to rebuild the stuff again. So yeah, so let's wait a few seconds and then see what happens there. Okay, so now I can just test if it's back. Okay, sometimes, okay, so now I have it. So now I'm just gonna go to my IDE. So what I'm going to do, I'm just gonna go into service here, and then I'm going to go to debug, so I can attach the remote debugger. What happened there? So I didn't stop one. Okay, let me see. Okay. So, okay. Okay, run JSON. It's fine. Okay, let me try this. Seems like something is going terribly wrong in here. Let me just close it. Let me just close IDE for a second, just to see what's going on. So I'm just gonna quit it. Maybe I'm running something there and I'm not sure of. Okay. Right. Okay. All right. So now I'm just going to try it again. See if it will run. Okay. Okay. So it looks like it's doing something. Just gonna check. Okay. Restart. I'm wondering if I change something there in the sync. I wonder if my ID is broken. Okay, it looks like my ID is broken or something. Close something. I'm not sure what it's asking me to close. Okay, yeah, I'm not sure what is happening there. Right. Yeah, but normally what will happen is when I do that, so I can sort of just go in and attach the debugger. That's kind of weird now that it doesn't work. I guess it's presentation stuff. Just stops working. Yeah, it was working just now. But yeah, I decided to stop. Doesn't want you to see the fun stuff. Yeah, just gonna try it. It's still asking me to do the same thing. Yeah, but yeah, normally when I attach the debugger, it'll just get my stuff across to the other side. So what I will do is I will try to do it differently. But I think probably maybe it's my IDE that is broken. Just try to close it once again. Force quit. Okay, force quit that. So that it can clean up anything that might be running there. Okay. Alrighty. Right. Okay, let me see. So I have everything here. For that, it's fine. Finding the right stuff. Okay. Let's see if I'll be able to open this again. Okay. Seems like there's something else going on there. Maybe it's accessing the same port. Yeah, I'm just gonna try to run it on the different port and see if it will work from there. Just patch this. Okay, let's see. Okay. Okay, let's just see if I try to run it. Different port, if it will work. Change a few things here. So let me just change it to 6,000. Okay. Then let's run this. Cool. Sure, I'll just try to run it again and see if it will work this time. Okay, now I'm just gonna put in that value just to see if maybe there's nothing conflicting. Yeah. Cool. So I hope the push will be much faster. Okay. Just in time, let me just change the launch. Change it to sync. I'm not using that one. Right. Okay. Right. Yeah. So presentations, they must have not working. Yeah. Okay. Right. See what happens. Okay, I can go and then try to. Okay, so it's back online. Okay, let's see if it will actually work. Just gonna wait for it to finish. Starting up. I'm just gonna run one test to just see that it's working. Okay, there it is. I'm just gonna try it now and see if it will work. So I have one remote. Okay, so there is connecting. So I think the issue might have been the port. So let's if we go back and then we go to maybe service here and then put a breakpoint somewhere there. So and then we try to call this. Might take a few minutes because of latency. I've seen that because I'm running my cluster in London region, so sometimes it takes a couple of minutes before I can see stuff coming to to my breakpoint. Let's see if it comes there. It's taking quite a while. I wonder if it's still working. Okay. This takes quite a while. Okay, let me see. Okay, there. So it just takes a while. I think it's because of latency or something for my breakpoint to my code to come to the breakpoint. So, but we can see that when we run in that debug mode, the one that we created, so we can also run debugger like we would normally do. So we can still change. We can still change the code. We can still change the code as well while we are in debug mode, because it will still sync the files, our local files with the container, and then it will still restart the container. Yeah. So yeah, so that's about it from this section. I'll just disconnect. Okay, cool. So now I'm going to the last part, which is I can show you the terminal, but the terminal is it's just gonna start the whole. It's not gonna give us the logs. It's just gonna start it in terminal mode. So in that terminal mode, you can run any command that we want to, but then it still gives us the syncing between the local and the container. Yeah. So now I'm just gonna go to just purge. I like cleaning up. So purge, just cleaning up space, and then I'm going to go to this the front end. So this application has so the front end is dependent on the stock manager and then the product catalog. So now just gonna check yeah, the normal ritual with what do you call DigitalOcean is taking time in that mode. So I have to go delete stuff, force delete, so that I have a clean environment. Okay. Okay, it was gone. So here it's going to what it's going to do for this one. So if we go to a section, the shop one. So we see the DevSpace there. Let me just remove everything there. So from there, it's still the normal things that we have seen. but then it has this additional section, dependency section. So in the dependency section, we're saying, yeah, it has dependency, which is the product catalog, and then it has the stock manager as well. So when we say skip, skip, it will only deploy without building the images. So I'm gonna run this, see how it's going to deploy everything. So after that, we also have this section here. Just wanna show you here. So it will also open this URL here. So just gonna try it, see if it works. Still run the same command, the space dev. Hopefully it takes short time to do stuff. So it's applying. So it starts by applying dependencies first before it actually applies the application that we are actually developing. Yeah. So it will do the normal push and stuff. Yeah, and then we'll see when it's done. So it will start streaming the logs like we normally see, and then we'll have. So when it's done here, it will open up the UI. So it will just open up the UI. So because this front end, we just tell it, okay, when it's done, just open up the UI. Yeah. So yeah, so that's yeah. So I just want to show you another interesting thing that I think it could be better. With a couple of things, like if it shows a couple of things, so it gives you this UI, so which you can see all the stuff that you have. I think it would have been better if they had like way to show us the resources as well, the utilization of resources, so in terms of so that we can optimize our code early before we actually push it, and then we realize that it's failing somewhere down the pipeline because of some optimization issues. Yeah. Yeah, so if you have a running stuff, you can also run things like DevSpace. I think it's enter DevSpace. Okay, I think that would. So enter. So it will sort of give you the terminal, so you can get into the terminal. Yeah, like how we would normally run it. Your normal, and you see that I don't have to go get the name of the pod. It will just show me everything there. Then I'll just have to select and stuff. It makes things quite easy because they are sort of in one place. Yeah. So yeah, that's sort of about it from there. So yeah, it's quite an interesting tool that I see that it has a lot of potential. It still has some few improvements that can be done to it, but it's fulfilling you, I think. Yeah, and then the question now from here is how do we actually share our environment? So I guess maybe we'll talk about that in our next talk. How can we get our developers to actually share the environment while we using the DevSpace as well? Yeah, so that's about it. So thank you very much. Yeah, are there any questions?
Cool, awesome. Yeah, thanks, Lepolesa, for the great presentation and the demo. I think everyone's very impressed on how you stuck with your live debugging session and managed to make it work. That's really awesome. Yeah, so like Lepolesa says, if you have any questions, yeah, feel free to unmute yourself and ask Lepolesa directly. Let me just check the chat panel to see if there's any question here. So we've got the first question from Calvin. literally is about the sharing of the development environment, which will be your next talk. So I don't know if you want to address it now, maybe just give an overview, or should Calvin wait for the next talk? So his question is, how would it work with multiple developers working on an application? If two developers have the DevSpace clients connected to the cluster with autosync enabled, would it create an infinite loop of syncing?
Yeah. So what happens is that the way you'd normally share it between developers is you'd go as far as maybe segregate your environment per developer, but there are tools that you can use to segregate your environment per team. So, and then sort of creates virtual clusters. So I think those tools will actually help address that issue where you have multiple people working on the application and then having the syncing issue, because what happens is when you start doing something, it will kind of not override what's already there. So if it finds that this is already running, it doesn't override it. It will only override if there is a change on it, if there's something new that is in there. But I see as the so a quick solution would actually be to sort of partition your environment as per developer. So if I'm in the team of 3 people, we just sort of have our sort of slices of the cluster, and then have our own little namespaces with little resources maybe. And then, yeah, so sort of run our stuff from there without really affecting each other. But I think with the stuff that is now coming in with virtual clusters, that will be addressed. So yeah, maybe it's the next tool that we will look at, and then how we can sort of solve those issues. Yeah, we come up with a nice tool and introduce more problems. Yeah.
Awesome. Yeah. So yeah, we looking forward to the next talk about that. So the next question is from Calvin. DevSpace versus Scaffold. Your thoughts?
Sure. I don't know much about Scaffold. Yeah, I'll look into it maybe, and then yeah, comment on it. Yeah.
Okay. Awesome. So don't see any other questions in the chat.
Just one from me, Henry. Sorry, I'm tired of typing today. So apologies if I missed it. You know, so for a complete development experience, obviously the guys need to change variables, right? You know, so at least in our environment, a lot of that is driven by you know, environment variables seeded from config maps. How do we empower that? You know, with this tooling for guys to be able to maybe change, you know, DB parameters or whatever the case that is being consumed, if that makes sense.
Yeah. Okay. Yeah. So for environment variables, so either you can sort of use the patch. So there's a mechanism to actually patch, or because if I go back to my so because now the environment is not lives very closer to the developer, so they can do some changes actually here, because there is a reload, auto reload that happens, so they can actually add files here that will change. Let's say you're using Helm, and then you have values file, and then they want to change something in the values file to just append something, so they can append it here, because now everything is just closer to it's actually inside the code base, so they can sort of make changes there.
Great, perfect.
That answers the question.
Certainly. So there's a manifest, and we could see that from the manifest, and you could potentially patch that with a config map that might exist already, or patch it locally.
Yeah.
Okay. Perfect. Thanks.
Cool. So the floor is open. If you have any other questions, you can just unmute yourself and ask. So I have one question, Professor, while we're waiting. So I see that in your DevSpace.yaml, you've got a production profile, right? So
Yeah.
like what you've been demoing is sort of more from a developer's perspective, right? That they can just use the single binary, which is DevSpace, and then they can just like run the whole, compiling of the artifact, building a Docker image, pushing the Docker image, and then deploying the deployments into Kubernetes. So is it cool to say this all-in-one tool can also be incorporated into any of the existing build tools that we have in our CI/CD pipeline? So because a lot of times, like, we find ourselves like maybe writing Jenkins or even build specs where we literally write out the entire Docker command, like, Docker build and then Docker push and then Docker pull and then run kubectl commands. And with this, like the best thing about this is like all of that thing is abstracted away, right? So you just have a single configuration and you just define it and then it just does everything in the background. So do people incorporate this into their build pipelines? Yeah,
so you can incorporate it into build pipeline because it also has a dev command, deploy command. So let's say you have been developing and then you are done developing. So we know that when you develop, you have been changing a lot of things, right? So you are at that point where you say, hey, I'm done developing. I just want to test my final thing. If this thing will be production ready, you can just go in and run DevSpace deploy, and then you give it a profile, the production profile, and then it will deploy it the same way it will be deployed in your maybe in your next environment. Like maybe if you deploy, you're going to deploy to staging, then it will deploy the same way. So whatever you'll be building in that deployment, in that profile, is exactly what is going to be running in production. Yeah.
Yeah, awesome, thanks. Cool. Are there any other questions for Lepolesa? Nope. Okay, cool. All right, great. Yeah, thanks, Lepolesa, for a great presentation. So that's all the time we have for today. Just an ending note, we're always looking for speakers to come and share with us their cloud native journey. So please reach out to me if you're interested in becoming a speaker. So thanks for joining us today. The webinar recording and slides will be online over the next 2 days. And we're looking forward to seeing you in our next month's CNCJ meetup. Have a great evening, everyone.